we will be discussing the introduction to sensors. Okay. So overview. So what are sensors? What are commonly detectable phenomena? What are the physical principles or how sensors work? And why do we have the need for sensors? And then what do we need to understand when choosing a sensor? And then examples. Okay. So what are sensors? According to American National Standard Institute, or ANSI or ANSI, right, so it is a device which provides a usable output in response to a specified measurand. When we say measurand, this one, we are referring to the measured quantity. Okay, so we have an input signal that will pass through the sensor. The sensor will sense the input signal, and then it will produce an output signal. Okay, so let's leave it at that. We will discuss more of it later. So a sensor acquires a physical quantity and converts it into a signal suitable for processing. So example, optical, electrical, mechanical. So nowadays, common sensors convert measurement of physical phenomena into electrical signals. Because again, everything is now being converted into digital form. So the active element of a sensor is called a transducer. Okay. So a device which provides, go back to the definition of our sensor, a device which provides a usable output in response to a specified measurement. So I guess the good example there is the capacitive touchscreen of our smartphones. Okay. The input signal is our touch. The output signal is whatever icon or whatever function that you are trying to execute on your smartphones. Okay. Another example is a microphone. So a microphone is a sensor. The input signal is our voice. The output signal is an electrical signal that will be processed by the amplifier, and then you can hear it to the speaker. So that's an example of a sensor. What else? We also have like light sensors, for example. In our street lights, which are automatically turning on during the night and automatically turns off in the morning. Usually there is an optical sensor in there that is detecting light. So if there's still light, if there's still light from the sun, the lamp will not turn on. When the sky turns dark or there's no more sunlight, so the lamp will turn on. Okay. So this is right. Anyway, the active element of a sensor is called a transducer. What is a transducer? Transducer is a device which converts one form of energy to another. Okay, so in the case of sensors, or in our case, which we are trying to process signal, usually any energy is converted to electrical energy, because electrical energy is one that can be processed by our devices. Okay, so when input is a physical quantity and the output is electrical, it is called a sensor. When the input is electrical and the output is a physical quantity, that is called an actuator. Okay, I think one word we can use for actuator is output. Okay, I'll give an example. Let's have microphone and loudspeakers. Okay, when we speak to the microphone, the input there is our voice. The output of the microphone is an electrical signal. So the microphone is a sensor, right? And then that electrical signal will pass through the amplifier, will go to the speaker, The electrical signal that goes to the speaker is being converted into sound, right? Okay, so the input of the speaker is electrical, the output is sound, which is a physical quantity. So the speaker is an actuator. Okay, so the microphone, sensor, speaker, actuator, but they're both transducers because they're converting one form of energy to another. All right. All right. Another example. Nowadays, our water heaters are automatically turns off when the water boils, right? Right. So the input of the sensor or the sensor being used in our water heaters is temperature sensor. Once it uh, once it detects 100 degrees Celsius temperature, it will turn the heater off. Okay. So the input there is temperature, a physical quantity. The output is electrical, which turns off the switch. Okay, so that's an example of a sensor. Okay, so let's proceed. So commonly detectable phenomena. So we have biological, electrical, electromagnetic, heat or temperature, magnetic, mechanical motion, optical, and radioactivity. Okay, so almost all of these phenomena can be detected. We can use sensor for all of this. So we will discuss each of them as we go along. So physical, you have thermoelectric, thermoelastic, thermomagnetic, thermooptic, photoelectric. As I've given you an example on the water filters, the thermoelectric. So the trigger is temperature, then the output is electric. Okay. Then, of course, not all of the time the sensors will output electrical signals. There are sensors, there are still manual sensors that does not use electrical systems. Okay, so some of those are relays. If you're familiar with a relay, I think you're fourth year now, right? Third year, 4 years. Okay, so relay is an example of a sensor in which an electrical signal is being sent and then a physical switch will trigger. So it will either turn on or turn off depending on that electrical signal. So that is example of electrical to physical. Okay, so next we have chemical. So chemical transport, physical transformation, electrochemical, etc. So the chemical sensors are actually kind of advanced level sensors, but we have simple chemical sensors as well. So if you still remember litmus paper, which indicates if a liquid or if a solution is acidic or base, it will change color depending on the level of acidity of a solution. So that's the example of sensor. Okay. Next, we have biological transformation, physical transformation. So maybe the increase of temperature of a body, biological body, or producing chemicals. When a body produces certain chemicals, the sensors can detect that. Right. Commonly measured quantities. So we have acoustic stimulus and then quantity. So acoustic, we have wave, spectrum, wave velocity. We have biological and chemical, so the concentrations. Electric, so charge, voltage, current, electrical field, activity, permittivity. Right. Magnetic, so magnetic field, flux, permeability. Optical, so refractive index, reflectivity, absorption. Thermal, so temperature, flux, specific heat, thermal conductivity. So mechanical, position, velocity, acceleration, force, strain, stress, pressure, and torque. So these are the commonly measured quantities. So since they are commonly measured, meaning a certain sensor must have been manufactured for the use to measure these quantities. Physical principles or examples. These are the principles being used by sensors on their function. So we have Ampere's law. So a current carrying conductor in magnetic field experiences a force. For example, say galvanometer. We will encounter this in our later topics. Curie-Weiss law. So there is a transition temperature at which ferromagnetic materials exhibit paramagnetic behavior. Right? So there is a certain temperature in which some metals becomes magnets. Right? Faraday's law of induction. So a coil resists a change in magnetic field by generating an opposing voltage or current. Right? So this is usually used to measure or to detect magnetic fields. Used to detect metals, I think. And then a photoconductive effect. So when light strikes a certain semiconductor material, so the resistance of the material increases. Example is a photoresistor. Choosing a sensor. So when choosing a sensor, so we have so many factors to consider. So we have environmental factors, and then economic factors, and then sensor characteristics. So depending on the use, depending on where it will be used, depending on the longevity of the measurement needed, right? So a lot of factors comes into choosing a sensor. So you have for environmental factors, temperature range, humidity effects, corrosion size, overage protection, stability to electromagnetic influences, ruggedness, power consumption, self-test. Economic factors, we have cost, availability, and lifetime. Sensor characteristics, you have sensitivity range, stability, repeatability, linearity, error, response time, and frequency response. Okay. So why do we need sensors? So sensors are pervasive. So they are embedded in our bodies, automobiles, airplanes, cellular telephones, radios, chemical plants, industrial plants, and countless other applications. When we say pervasive, let's make pervasive easy. When we say pervasive, usually it is already included in a certain system. Okay. So for example, like for example in a water heater, so the temperature sensor is already inside the water heater. You don't need to buy an external sensor for your heater to automatically turn on or turn off. So it is usually already embedded or included inside the system. It is easy to integrate into systems. Okay. So without the use of sensors, there would be no automation. Imagine having to manually fill those water bottles. Okay. Sensor is the main reason why we have automation. One of the biggest movers to the automation industry. Okay. So we have motion sensors. Monitor location of various parts in the system. So absolute or relative position, angular or relative displacement, proximity or acceleration. Principle of operation, magnetic resistive, capacitance, inductive, eddy current, etc. Okay. Motion sensors, good example there will be photo motion sensor wherein it transmits light, and then if something is disturbs the line of sight of the light that is being transmitted by the sensor, so there is something that is moving. Okay, so it can detect that there is motion. Then we have other principle of operation. We have magnetic, resistive, capacitance, inductive. Okay, so this will be better. This will be explained better if we will explain it through the sensor itself. So let's proceed. So strain gauge, motion, stress, or pressure. Okay, so strain gauge is used to measure deflection, stress, pressure, etc. So the resistance of the sensing element changes with applied strain, or a Wheatstone bridge is used to measure small changes in the strain gauge resistance. You can usually find strain gauge sensors in water systems. Okay, a strain gauge is one of the sensors used to detect the pressure of water. Okay, when the water applies a high pressure, so the strain is smaller, or the strain is bigger on the sensor. Okay, so this is kind of a flexible spring type, spring-like material or metal. Right? So when you apply a huge pressure, so it will compress. If the pressure is less, so it will relax. Right? So it can detect or it can compute the water pressure depending on the compression of the string or the gauge. Right? Next, we have bimetallic strip. This is usually used in temperature switches, okay, wherein the system will turn on or turn off depending on the current temperature. Okay, so we will discuss the formulas in the later topics anyway. So application, thermostat, okay, turn on and turn off. How does this usually happen? So there is a current in here passing through these two metals, okay. So this is part of the conduction. Then when we apply a high temperature in these two metals, so they have different, what do you call this? They have different, usually these are made up of two different metals, right? So one has a higher temperature coefficient than the other, right? So one will curl up faster than the other, right? Then they will separate. These two will separate. When they separate, then the current will not flow within the system. So the current stops. So the switch turns off. Okay, so that's how usually a bimetallic strip works. Next, RTD, or resistance temperature device. Okay. So we have this formula wherein the resistance of a metal changes due to temperature. Okay, so this is the temperature coefficient. Okay. Again, the resistance of a metal changes with temperature. So it can go higher or it can go lower depending on the temperature. This change in resistance is calculated and then calibrated to show the accurate temperature reading. Other temperature sensors, so we have thermistor, same concept. So the resistance changes with temperature. And then thermocouple. So this one is usually used for switching, because a difference in temperature between the two, this is using bimetallic strips. So a change in temperature, rather when the change in temperature can produce voltage. Okay, so this is used for detection if there is a change in temperature. Next, we have capacitance transducers. This is the one being used usually in automated factories, okay, in filling factories, like filling the water bottles. Okay, so you have if you still remember the concept of capacitance, so we have two plates and then the dielectric in between. So if you set the computation to dielectric of air, for example, usually in factories, okay, and then there is an object in between the two plates, for example, a bottle of water filled with water. So the dielectric changes. Instead of air, there will be water in between. So the capacitance changes. According to this change in capacitance, you can set or calibrate what the function you want the system to do. Okay, and then what else? Of course, if there is no disturbance in the capacitance, meaning the bottle is empty or whatever you're trying to fill is empty. So you can also set that if the capacitance is at this value, which is an empty bottle, equivalent to empty bottle, so the system will fill that certain area. Okay, so this is usually the use of capacitance transducers. Nowadays, most of smartphones are using capacitive touchscreen. Okay, so same principle. So our touch or our fingers produces a difference, introduces a different dielectric on the two plates. So we are causing a change in capacitance when the screen detects a change in capacitance, meaning there is an input, there is a touch, there is supposed to be a command that is supposed to be followed. Okay. Next, we have accelerometer. So this is a more complicated sensor. So accelerometers are used to measure acceleration along one or more axes and are relatively sensitive to orthogonal directions. Applications: motion, vibration, blast, impact, shock, and wave. So mathematical description. Okay, it's beyond the scope. Type of accelerometer. Applications of accelerometer. So accelerometer is used to measure acceleration. So of course, depending on the system, it will you can set what it will supposed to do when there is change in acceleration. Usually in automobile sorry, applications, if you've heard of a what we call ABS or anti-lock braking system, right? That is when you suddenly press the brake, right? If the car is manual and you suddenly press the brake, there is a chance that you will lose control of the car or you will skid on a great rate that you will lose control. But if you have anti-lock braking system, so it will detect a sudden change in acceleration. Okay, so instead of letting the brake stop the car suddenly, it will make the car stop in intervals. So you will not lose control of the car. So that is a very good security feature of the automobiles. Okay, so I think that's all for now.